Hi, everyone. So today we discussed carbon dioxide. Um, and today we discussed carbon dioxide and how it affects Earth's temperature, or rather, Earth's global temperature. This is still part of climate change basics. This is the last lesson of the climate change basics. And so after this lesson, or after this week, we are going to start getting into the specifics of climate change. So let's go ahead and let's get started. So today's warm-up question was, how does carbon dioxide affect temperature? So you can look at this graph to help you out if you want. How do you think carbon dioxide affects temperature? As always, please avoid using Google. I just want to know what you know or what you think or what you remember. So go ahead and pause the video right here and answer the warm-up question on Google Classroom. It's called Lesson 28 Warm-Up. I'll give you a few seconds to do that. Okay, so you should have paused the video just now and have gone to Google Classroom to answer the warm-up question. We're going to talk about it in a little bit. But really quickly, so today's agenda, we just did the warm-up. Next, we're going to do a greenhouse effect simulation, which we'll talk about in a bit. And then lastly, we'll do a carbon cycle review. So today's focus question is, how do greenhouse gases in the atmosphere affect Earth's temperature? We're going to talk about greenhouse gases in just a moment, but we are asking today how those greenhouse gases are going to affect Earth's temperature. Cool. So let's talk very quickly about carbon dioxide. So carbon dioxide and temperature have a pretty clear relationship. You can see from this graph that whenever carbon dioxide is up, so is temperature. Whenever carbon dioxide is down, so is temperature. And so we know that carbon dioxide causes increases in temperature, or decreases if carbon dioxide goes down. But we do know that temperature follows carbon dioxide. And again, if we look at this graph, you might say, oh, but Mr. Bean, carbon dioxide goes way up towards the present, but temperature isn't following it. That would be true. Temperature has not followed it yet, but it will very soon. All right. So carbon dioxide and a few other gases are all called greenhouse gases. And greenhouse gases are called greenhouse gases because they heat up the Earth, a lot like a greenhouse used by a farmer to grow plants in a cold season. So I don't know if you've ever been to a greenhouse, but a greenhouse is this really warm, sunny place. The walls and the ceilings are all made of glass. And so what happens in a greenhouse is light can go through the glass ceilings and the glass walls into the greenhouse. And where plants can use the light for photosynthesis, but also the greenhouse room, it actually traps all the heat that's coming in from that light, because the light can come through the glass ceiling and walls of the greenhouse, but it can't get back out. And so greenhouses are pretty warm, even in cold seasons, and it's because they get a lot of light. So today we're going to look at why or how carbon dioxide and other greenhouse gases and temperature have this relationship where carbon dioxide increases temperature. So to help us understand how carbon dioxide increases temperature, we're actually going to look at a simulation today. And this simulation is on this simulation is on FOSS-Web, which you've used before. So what we have, let's see if I can move my face. All right, cool. So what we have is this module is called the greenhouse effect. So it's going to model for us how the greenhouse effect works. The first thing you're going to notice is that there are these arrows coming down from the sky. So the blue arrows and the red arrows are different. They mean different things. The blue arrows are light. This is actually visible light energy coming from the sun. So this is light in the way that we think of it. This is the light that we can see. So the blue arrows are light that we can see. The red arrows are infrared energy. So this is energy that's coming to the Earth in the form of infrared. Infrared energy comes from things that are emitting heat. So this infrared energy is actually coming from the sun, which is really hot. And this energy, it can actually it can warm whatever it is hitting. So we have these two different kinds of energy. We've got visible light energy and infrared energy. They're all coming down from the sky. Next, you will notice that we have a temperature, a thermometer. A temperature gauge is what I was going to say, but this is a thermometer. On the left side, we have degrees Fahrenheit. So this is the system we usually use in the United States. And on the right, we have degrees Celsius, which is what they use everywhere else. And you're going to see that right now, it is -1 degrees Fahrenheit. That's because right now we have it set that there is no greenhouse gases in this system. So in this system, there is no carbon dioxide. When there is no carbon dioxide or other greenhouse gases, it actually it causes a very cold planet. And that's because greenhouse gases, they can actually trap infrared energy. So we're going to see this a little bit later, but greenhouse gases trap infrared energy. They cause the infrared energy to come right back to the Earth. So it's very difficult for infrared energy to leave the atmosphere. Visible light, on the other hand, visible light, on the other hand, leaves Earth very easily. And so it's actually a good thing that we have greenhouse gases. Without greenhouse gases, this would be a very cold planet, and actually it'd probably be very difficult for life to exist here. All right. So while we are looking at the simulation, you're going to have a worksheet to fill out. The worksheet looks like this. At the top, it says lesson 28 greenhouse gases in the atmosphere. So what you're going to do, you're going to look at the simulation as we go through it in this video, and you are going to fill out some different information about different concentrations of greenhouse gases, or different concentrations of carbon dioxide. So the things you're going to fill out are heat energy, which are the number of red arrows. Then global average surface temperature, so that's like the temperature according to the thermometer. And lastly, CO2 in parts per million. So the way that we're going to do all of these, the first one is heat energy. I'm going to pause the video, and you are going to count how many red arrows you see. That's what you're going to do for the first column. For the second column, global average surface temperature, you're going to take the temperature from this thermometer on the right. And then lastly is carbon dioxide in parts per million. You can read that either right here, where it says CO2 equals 0 parts per million, or you can read it down here, 0 parts per million. So let's go ahead and do this together for the first one. So I'm going to pause the video. All right, or pause the simulation rather. So now we're going to count how many infrared energy arrows that we see, how many red arrows we see. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 red arrows for no greenhouse gases. All right, the global average surface temperature is -1. -1 degrees Fahrenheit. The unit's really important. And then lastly, CO2 in parts per million. We can see here that the CO2 is 0 parts per million. There's no CO2 in this simulation right now. All right, so we're going to write 0 parts per million. Great. So now what we're going to do is look at the CO2 levels in 1750. So if we go back to our simulation, we are going to click on levels in 1750. But we're going to see how this changes our simulation. So in 1750, there was 280 parts per million CO2, or 280 CO2 parts per million. And that is like around Earth's average carbon dioxide levels. So let's take a look at how our atmosphere changes. Okay, so the first thing you're going to notice is that temperature is increasing pretty rapidly. Another thing you're going to notice is that suddenly these red arrows, when they reflect away from Earth, like this one right here, at some point it gets stopped by something. Oh, maybe not that one. Okay, but some of these red arrows are going to stop, and they're actually going to be reflected back. So like that one right there, it didn't leave the atmosphere. It got stopped by something. And when it gets stopped, it actually gets re-radiated. So it gets sent back out again, maybe back to Earth, maybe towards the atmosphere. But at any rate, so we can see that the temperature is about 56 degrees. So this is much warmer than -1 degrees Fahrenheit. So again, we're going to go ahead and count the red arrows. And yeah, we're going to go ahead and count the red arrows. So we have, looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've got 13 red arrows for levels in 1750. The global average surface temperature was about 57 degrees Fahrenheit. And the CO2 in 1750 was about 280 parts per million. All right. And so you may be wondering, why did we choose 1750? Why is that a special year? And that would be a good question. That's actually right before the Industrial Revolution started. So back in 1750, we weren't using a lot of machinery yet, and the machinery that we had didn't really require a lot of energy. So in 1750, we were not yet burning fossil fuels. Actually, in 1750, we weren't burning a lot of fuels at all because we just didn't need that much energy. And so 1750, this 280 parts per million, that is sort of like maybe like the natural levels of carbon dioxide. This is how much the carbon dioxide would be if we humans were not affecting it. All right. And actually, before we move on, I wanted to show you something. So if we go to show greenhouse gas particles at the bottom, if you turn on, you're going to see all these different carbon dioxide molecules. And you can actually see that when the red arrows hit one of these, oh, okay, so the animation is not perfect, but what happens in the real world is that when this infrared energy hits one of these carbon dioxide molecules, the carbon dioxide molecule absorbs it and then re-radiates it. So that means that like this red arrow is going to get hit. Okay, so it hit this carbon dioxide molecule. Then this carbon dioxide molecule actually sends it out again. Like I said, could send it back to Earth, could send it kind of sideways, or it could go back out the atmosphere. Right? So now we're going to go ahead and we're going to take a look at what the current levels of carbon dioxide are doing to the Earth. So now I've chosen 400 parts per million of carbon dioxide. That's about how much it is right now. Actually, I think right now it's 405, but that is very close. And again, I'm going to pause the video. You're going to count the red. You're going to count the red arrows, take the temperature, and then record the parts per million. And you're going to do all this by yourself this time. So pause the video. Actually, that's a bad place. Okay, pause the video here. Go ahead and count the red arrows. All right, and then go ahead and take the temperature. And lastly, record how much carbon dioxide there is in the atmosphere. Okay, so so there's something that I noticed here. The underneath current levels, where I selected current levels of greenhouse gases, the concentration is 400 parts per million. If you look over here on the right, it actually says carbon dioxide is 388 parts per million. And that's because there are a lot of different greenhouse gases. Carbon dioxide is the main one, or it's the one that we have the most of in the atmosphere. But there are other greenhouse gases, and some of them are actually are even worse than carbon dioxide. But they're in such small amounts that we don't worry about them as much as we worry about carbon dioxide. So you could record either 400 parts per million or 388 parts per million. 400 would be greenhouse gases, like total greenhouse gases, whereas the 388 would be the total carbon dioxide. Okay, all right, and now we're going to take a look at what would happen if our atmosphere had lots of greenhouse gases. So I'm going to click on lots of gases in the bottom, and we are going to see what happens. All right. Cool. So you probably, the first thing I noticed was that the temperature went way up. We're now at 71 degrees Fahrenheit. You'll also notice that there are a lot more red arrows. If you turn on greenhouse gas particles, you're going to see, whoa, the screen is just all these greenhouse gas molecules. Anyway, so again, go ahead and record the red arrows, record the temperature, and record the parts per million of carbon dioxide, which for this one we'll just say is 580 because it gives us kind of a range in the bottom right. All right, so go ahead and pause this video while you do that because I'm just going to start talking in 3 seconds. Okay, so this this 580 parts per million, this is a lot more than we have right now. This is a lot more carbon dioxide than we have right now. Right now we have 400. 580 would take us quite a long time to reach, but scientists are worried that one day we could reach this temperature, or we could reach this this amount of greenhouse gases. And what's worrisome about that is that the average temperature on Earth would be 71 degrees Fahrenheit. You might be thinking, wow, that's nice. That's like early summer temperatures, or I guess here in Kentucky, that would be like spring temperatures. And yeah, you're right. The weather would be it would be quite nice for us, but that is 16 degrees higher than the temperature in 1750. That's like 14 degrees higher than the average temperature right now. And so warming the Earth by 14 degrees, warming the Earth by 14 degrees would probably decimate, like totally destroy most ecosystems. Even right now at 400 parts per million, the average global temperature, I think it's at 59 degrees. Already that's too much. 59 degrees is already too much. 71 degrees would be horrible, because we would, like I said, we would destroy all of our ecosystems probably. But also we'd probably become too arid of a planet, too dry. It might be hard to grow food. We might not have enough fresh water to drink. This is a worst case scenario. But from the simulation, we saw that when you increase carbon dioxide, or when you increase greenhouse gases, temperature also increases. And the reason that greenhouse gases are increasing is because we are adding more carbon to the atmosphere. So now we have lots of machinery that requires a lot of energy to run. So we're burning a lot of fuel. And that's how all this extra carbon is getting there. So now what we're going to do is watch a video just kidding. So now what we're going to do, sorry, I totally forgot about this. Now I would like you to answer these 3 questions about the simulation. So number 1 says, cause and effect. When you increase the amount of greenhouse gases, what happens to the amount of heat energy, or red arrows, in the atmosphere? Number 2, when you increase the amount of greenhouse gases, what happens to the global average temperature? And number 3, why does more carbon dioxide in the atmosphere lead to more heat energy, or red arrows, trapped in the atmosphere? All right, so go ahead and pause this video while you answer these questions, and then we will move on. Cool. All right. So the next thing that we're going to do is we're going to watch a carbon cycling video. I can't actually show you this video in my video because I learned that when I show a YouTube video, you can't hear the volume, or you can't hear the audio. So go ahead and click on this link and watch the video, and then answer these 3 questions. The 3 questions are: what are some ways that carbon dioxide enters the atmosphere? Number 2, what are some ways that carbon dioxide leaves the atmosphere? And number 3, what are some ways that humans are changing the amount of carbon dioxide entering the atmosphere? So go ahead and watch the video and answer the questions. And when you're done, come back to this video and press play again. So pause here, watch the video, answer the questions, then come back, press play. Cool. So the last thing we're going to do today is investigate where the human-caused sources of carbon dioxide are. So there is another FOSS-Webb simulation. And this simulation is going to take us through some different places where humans are adding carbon dioxide to the atmosphere. So you're actually going to do this by yourself. The link is going to be at the bottom of the worksheet that you were just on, and you're going to press start. And then you're going to push this arrow down here, this blue arrow. You can read this if you want, but I'm also going to explain it. So this is going to take us through different points in time. And at each point in time, it's going to tell you how much carbon dioxide there is in the air. And it's also going to tell you your score. So somewhere in the simulation, there are 12 places where humans are adding carbon dioxide to the atmosphere. Your job is to find all 12. To find all 12, you're just going to click on it. So, for example, there is this little campfire here. That's probably a source of carbon dioxide. So if we click on it, you'll see my score went up by 1. So I found one of the 12. I only have 11 more to find. And it's going to tell me why this is a source of carbon. So it says burning wood, a type of solid biomass, is the predominant energy source in the world as the fuel is plentiful and inexpensive at this time. So in the 1700s, there was a lot of wood, and it was pretty cheap. Just had to chop it down. So this is the first source. Right? So you're going to find the other 11 sources on your own. When you find them, make sure you read why it's a source. Yeah, because this is going to be a bit of a preview to when we learn a little bit more about climate change after winter break. Right? And so that's all that we have for today. I hope you guys had a good day, and I'll see you next time.